So 8.1, we're going to learn about sequences and series. So we have two types of sequences. An infinite sequence means that there is no ending. Infinite, no ending. And finite sequence has an ending. The terms of a sequence are the numbers that we get. So A1, A2, A3, this would be like term 1, term 2, term 3, term 4. If we had a sequence that was like 2, 4, 6, 8, this would be term 1, term 2, term 3, term 4. So those are the terms. For this section, when doing your homework on WebAssign, it's super important that you show your work for everything. A lot of this could possibly be done in your head, but you need to show your work. So show your work for everything. So looking at example 1, it asks us to write the first 4 terms of each sequence. So we are going to find A1, A2, A3, and A4. So this just tells us we plug in 1 into our n. So this would be 3 times 1 minus 2. What's 3 times 1 minus 2? 1. Awesome. Next, we plug in 2. So 3 times 2 minus 2. 4. And then next, we plug in 3. So 3 times 3 minus 2. 7. And then lastly, we plug in 4. So 3 times 4 minus 2. 10. So those are the first 4 terms in our sequence. We do the same thing for B. So we have to find A1, A2, A3, and A4. So we're going to plug in 1, 2, 3, and 4. So we have 3 plus negative 1 to the first power. What would this be?
4.
What is negative 1 to the first power?
Negative 1 times negative 1?
First power, so it's just negative 1. If it was squared,
yeah,
then it would be positive 1. So what's 3 minus 1? 2.
2.
All right, next we plug in 2. So we have 3 plus negative 1 to the second power. What is negative 1 to the second power?
1.
1. So what's 3 plus 1?
4.
4. Next we plug in 3. So 3 plus negative 1 to the third power. What's negative 1 to the third power?
Negative 1.
Negative 1. What's 3 minus 1?
2.
2. And then 3 plus negative 1 to the fourth power. Negative 1 to the fourth power is 1. And 3 plus 1? 4.
4.
So these are the first 4 terms in our sequence.
Nope.
All right. For example 3, we have to write an expression for the apparent nth term a sub n for each sequence. So we are coming up with the sequence now given the first 4 terms. So we would do this by stating our first 4 terms. So for A, our first 4 terms are 1, 3, 5, and 7. So 1 is term 1, 3 is term 2, 5 is term 3, and 7 is term 4. So I'm going to make a little XY chart here for our terms. What do you notice is happening as we go up each term?
Going up by 2.
We are adding 2 to each term. So we have something constant that's being added to each term. Since this is a constant number that we're adding to each, our equation here would be like a linear equation. So we would think in terms of y is equal to mx plus b. where m is our slope and b is our starting point. So b is our y-intercept when y is 0, x is 0. So if we go backwards to this 0 point, what would we have to do to go backwards here? Subtract 2. So what's 1 minus 2? Negative 1. So our y-intercept is negative 1. So we have y is equal to our slope times x minus 1. What do you think our slope is?
1 over 1.
What are we
No,
increasing
2,
by?
2.
2. So our slope is 2. So we would have an equation that looks like this, but we want it to be in terms of a sub n. So how do you think we would make this in terms of a sub n? Awesome. an is equal to 2n minus 1. Perfect. So that would be our equation. So for example 3, this is like the tricky part of this section. As we go into 8.2 and 8.3, they give us formulas for this. So it gets easier. But I don't know why it introduces it not with formulas, I guess just to make us think a little bit. But this is probably the hardest this section's going to be, is coming up with these equations. Let's look at B. So here we have 2, 5, 10, 17. So our first term, second term, third term, fourth term. What do we have to increase by to go from 2 to 5?
3.
3. What about from 5 to 10?
5.
5. And from 10 to 17?
7.
7. So we're not increasing by a constant number here, so we're not going to use our linear equation. We're increasing kind of pretty quickly, so we're increasing exponentially, so we want to think in terms of powers maybe. So looking at our numbers up top, what terms they are. Thinking exponentially. What's 1 squared?
1.
1. So how would we have to go from 1 to 2? What would we have to do? If we're going.
You can't.
Well, what should we do to go from 1 to 2?
You'd add 1.
Add 1. So think about it in terms of 2 squared. What's 2 squared?
4.
4. And to get from 4 to 5, what do we have to do?
You add 1.
Add 1. And for 3, what's 3 squared?
9.
9. And to get from 9 to 10?
Add 1.
And 4 squared?
16.
And to get from 16 to 17?
Add 1.
Add 1. So what do you think our equation here is? We have a sub n is equal to what?
N plus 1.
What did we do? We took our term, squared it, so n squared,
N squared
plus
plus
1.
1.
Yep, so this is our equation here. All right, next we have a recursive sequence. So a recursive sequence requires us to plug in a number for n, but we also have to use the term before. So it'll always give us a term that we have to use to plug in, and we're going to find the next term in the sequence. So we use the previous term to find the next one. So if a sub 1 is 3, to find a sub 2, we would have to plug in 2 for k, and that would give us a sub 1 here. Does that make sense? So if we had a sub 2 minus 1, this was now a sub 1, so we're plugging in 3 into here. So we're just using the term before to find the next. So to find a sub 2, we would have 2 times 3 plus 1. So what's 2 times 3 plus 1? 7. Now to find a sub 3, we have 2 times, we use the term we just got before, so 2 times 7 plus 1. So it's 2 times 7 plus 1? 15. To find a sub 4, we use 2 times 15, so we use the term before, plus 1. What's 2 times 15 plus 1?
31.
31. And then to find a sub 5, what would our equation be? 2 times 31 plus 1. So what does that give us for a sub 5?
63.
63. So these are our first 5 terms of the sequence. It gives us a sub 1, and then we have a sub 2, a sub 3, a sub 4, a sub 5. All right, example 5, doing the same thing. So it gives us a sub 0 is equal to 1, and a sub 1 is equal to 1. So to find a sub 2, this is now a sub 2, so we plug in 2 for k. So what's 2 minus 2? Here. Which term is this asking us for? 2 minus 2 is 0. So,
0.
so we plug in
1.
a sub 0 here, which is 1. And then we plug in 2 for this k also, so this is asking us for a sub 1 here. So we have to plug in a sub 1, which is also 1. So a sub 2 would just be 1 plus 1. So what does that give us? 2. Good job, guys. So to find a sub 3, so we're now plugging 3 into k. So this is 3, this is 3, this is 3. So a sub 3 is equal to a sub 3 minus 2. So this is asking us to plug in a sub 1 here. So what's a sub 1?
1.
1. And then we plug in 3 for our k. So this would be 3 minus 1. So it asks us to plug in a sub 2 here. So what's our a sub 2?
2.
2. So what's 1 plus 2?
3.
3. So let's do it again. For a sub 4. So a sub 4, we have to plug in 4 for our k's. So what's 4 minus 2? 2. So it's asking us to plug in a sub 2 first. So what's a sub 2? 2. And then 4 minus 1 would be 3, so it asks us to plug in a sub 3 next. So it's a sub 3. 3.
3.
So it's 2 plus 3. 5. Next, we need to find a sub 5. So we plug in 5 for k. So here we have a sub 5. We have to plug in a sub 3 plus a sub 4. So what's a sub 3?
3.
3. And what's a sub 4?
5.
So what's a sub 5?
8.
8. All right, and last one, a sub 6. So we plug in 6 for k. So this is a sub 4 plus a sub 5.
So 5 plus 8.
So 5 plus 8. What's 5 plus 8?
13.
13. So our first 6 terms of the sequence, bless you, are these. All right, next we have factorial notation. So a factorial is this little exclamation point here. It's not just an excited N. It stands for whatever that number is and all the decreasing numbers behind it multiplied by each other. So if we had 5 factorial, this would be 5 times 4 times 3 times 2 times 1, which is 120. So 5 factorial would give you 120. So it just stands for all the numbers being multiplied behind it. An important thing to note here is that 0 factorial is equal to 1 and also 1 factorial is equal to 1. Just some special cases. So let's look at example 6. We have to write the first 5 terms of the sequence given by a sub n is equal to 2 to the power of n over n factorial. So we start with n is equal to 0. So we're finding a sub 0. So 2 to the power of 0 over 0 factorial. What's 2 to the power of 0?
1.
1. And what's 0 factorial? 1. So what's 1 over 1? 1.
1.
So that's our first term. Our second term would be a sub 1. So we plug in 1. So 2 to the power of 1 over 1 factorial. What's 2 to the power of 1? 2. And what's 1 factorial? 1. What's 2 divided by 1? 2. Next we have a sub 2. So 2 squared over 2 factorial. What is 2 squared? 4. And what's 2 factorial? So this would be 2 times 1, which is just 2. And what's 4 divided by 2?
2.
2. Next, we have a sub 3. So 2 to the power of 3 over 3 factorial. So it's 2 cubed.
8.
8. And then 3 factorial is 3 times 2 times 1. So this would be 8 over 6.
6.
What does 8 over 6 simplify to? 4/3. And then lastly, we have to plug in a sub 4, which is 2 to the 4th power over 4 factorial. So what's 2 to the 4th power? 16.
16.
And 4 factorial is 4 times 3 times 2 times 1. What is 4 times 3 times?
16 over 24.
16 over 24. What does 16 over 24 simplify to?
2/3.
2/3. Awesome. So these are our first 5 terms. Ready for the next one?
Yes.
All right. Example 7a. So it asks us to simplify. So on the top here, we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom, we have 2 times 1 times 6 times 5 times 4 times 3 times 2 times 1. So what on top cancels out with what on the bottom? 6, 5, 4, 3, 2, 1. So on the top, we just have 8 times 7. And the bottom, we have 2 times 1. So what's 8 times 7? 56 over 2. And what's 56 over 2? 28. Another way we could do this, save you a little bit of time, on the top, if you see you have 8 times 7 times 6, and then you just decrease from 6, this would be 6 factorial over 2 times 1 times 6 factorial. The 6 factorials would cancel out. So if you can see that right off the bat, go ahead and cancel them out. If you wanted to, you could multiply 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, get an answer, and then multiply 2 times 1 times 6 times 5 times 4 times 3 times 2 times 1, and get an answer, and then divide it that way. More work for you, but if you want to do it that way, do it that way. Any questions here? All right, let's look at B. So B is a fun one. We start with n factorial. So we start with n times what number is 1 less than n? What would come next? So to go 1 less than n, we say n minus 1. And then 1 less than that would be n minus 2, n minus 3, and then we just keep going. Dot, 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 dot. On the bottom, we start with n minus 1. What's 1 less than n minus 1? Not n minus 0. We're just subtracting 1 from n each time. So n minus 1 minus 1 would be what? N minus 2. So this would be n minus 2 times n minus 3. Dot, 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 dot. We could keep going. Do we see a pattern here? What cancels out? Everything except n. So n minus 1's cancel, n minus 2, n minus 3. Everything after that's going to cancel. So we are just left with n on the top. So n would be our answer. So next we have summation notation. This little squiggly line here is called the summation. It gives us a starting point down here. So this is where we start. And the number up top is where we end. So we plug in the starting point first, plug in every number in between that it takes to get to the ending point, and add all of those together. So summation, summation, sum, we have to add. So we just start with the starting point, end with the ending point, add them all up together. So let's take a look at example 8. 8a. What should we plug in first? What's our starting point? 1. We're going to start by plugging in 1. Then we need to plug in 2, 3, 4, and our ending point is 5. So we're going to plug in 5 numbers here. So start with 1. We have 3 times 1, which is 3. And then we're going to add our next number, which is going to be 3 times 2, because we plug in 2 next. So what's 3 times 2? 6. What do we plug in next? 3. So 3 times 3, which is 9. What do we plug in next? 3 times 4, which is 12. And then last, the 5. 3 times 5, which is 15. And then we just add them all up together. So 3 plus 6 plus 9 plus 12 plus 15. What do you get? Awesome. 45. So that is our answer. So when you first see problems like this little sigma here kind of looks scary, but it's really not that hard. Just start with the first number, end with the one on top, plug them all in, add them together. Not too bad. Let's look at B. What is the first number we have to plug in? 3. What's our last number we have to plug in? 6. So we're going to plug in everything in between. We have 3, 4, 5, and then 6. So we start with 3. We have 1 plus 3 squared. What's 1 plus 3 squared? What's 3 squared? 9 plus 1? 10. What do we plug in next? The 4. So 1 plus 4 squared. What's 1 plus 4 squared? 17. What do we plug in next? So 1 plus 5 squared. 26. And then lastly, what do we plug in? 6. 1 plus 6 squared? 37. Then we just add them all together. 10 plus 17 plus 26 plus 37.